Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. We will be presenting Project Mini IC Design, that is GCD, Greatest Common Divisor. My name is Muhammad Husni bin Muhammad Fadil Yusof, and with other 4 members, Muhammad Ali Najmi bin Muhammad Razi, Fikri Zulfikar bin Zaharin, Muhammad Irfan Farid bin Abdul Qadir, and Muhammad Rusti bin Rahimi. That is a list of content. First, introduction. Second, algorithm modeling. Third, RTL modeling. 5, data pack unit, control unit, top level unit, design verification of the circuit, and the conclusion. I will explain introduction. This project focus on designing and synthesis a 4-bit greatest common divisor, that means GCD, circuit using modulation of quarters. The design include algorithm modeling, RTL design, and simulation to ensure functionality. It consists of a control unit and data pack unit, both using positive edge triggering for synchronization. The final implement will be verified through simulation and demonstrate via a video presentation.
Okay, my name is Muhammad Irfan Farid. I will talk about algorithmic modeling. Algorithm modeling is the Euclidean algorithm. Is a method for finding the greatest common divisor, short form for GCD, of two or more integers. It works by repeatedly applying the formula GCD where A is greater than B. Compare the remainder R when A is divided by B until the remainder is 0. The GCD is when equal to the last non-zero remainder or the last B value.
RTL modeling. In this RTL modeling, we have a table flow. For the table flow, it has a state, and the next column is next state condition, and the next P selection, next for the Q selection, so that the P load and Q load, and put for output for enable, or it will synchronize as a enable, and the output done. After the last column is next state. In this table, it clear to show you how the state will go if it is triggered by something like state A ideal, B initial, C is selection signal, D comparison state, E is equal like P equal to P tolak P minus Q. For the F is a Q. For the F is Q equal to Q minus P. G and the state G is a waiting state, and H is a GCD found and output enable. So in this table flow, it will show to you how the state will go through, and what the output will become if the state is triggered. Okay, and the next is RTL design, data pack unit. In this data pack unit, I will show to you how the input and output and the processing the data, like P input P, it will go to the marks, and the mark has a subtitle for the input. For the subtitle, it has an input from the register. It will go back to the subtitle 1. Okay, and after that, the marks will go to the register. It has cycle, like cycle process. The register A, the first register will go the first register the first register will go to the comparison state and the subtractor. For the subtractor 1 and 2, it will go through by the register A, while the subtractor 2, it it will it will it will output for the subtractor 2. It will go to the marks 2, and the output from the marks will be go to the register, and register will out. Okay, and out we have a out 3 bit, and the PRT, PSQ, PLS. Okay, like there's for the input, it has the P, Q, something like that. Okay. Next, the control unit. In this control unit, it will show to you how the data controlled. Like the input, it will to go to the operation will go to the marks, and mark will go to the marks, and mark will go to the operation, like and it will go to the lash. After that, the lash will be combined it to the state. So state will be control the flow of the system.
As my friend has shown in the previous slide, this is the top level RTL design. For the P value and the Q value, these two numbers will be used to insert data and be processed through the data pad. Will contain ALU that will proceed with the value that has been insert to the system. Both of these are complement to each other by controller that become its own unit state machine to control the state of every data has been processed. And the result for the processing data will be like this. For the clock that is always 1 and 0, and reset at some level, it will trigger and will activate all the data. For the beginning part, there will be 0 data that will be processed first. So at the go value is the enable point for the system to activate their processing. At this level, it will send the instruction go to the controller, and the controller will send the output enable to the data pad, which is contain all the component inside the data pad. For the GCD, the method is using like this: the sort number including the order of 4 and 50, which means the data they will arrange first before they do anything, as they use in the data pad system and data pad component. The smallest number will act as the divisor, then will be modulo quotient of the remaining number, and the divisor 15 mods with the 4 equal 3, which means in the data pair there will be 3, and then it will be insert to the register for it to be set as the next greater number. Just because of the number 4 is the highest number than the 3, the 3 will be the divisor, and it will proceed the same until it become the number that cannot be divided anymore. So if now the input is 15 or 1111, and the second input is number 4, this value then inserted being processed through the system and the state until it become 1. From this verification show that the system has succeeded. After the value has done, after the value outputted, the done set flag has been raised. That's all for my part. We proceed to the conclusion.
What we can conclude is the simulation result confirm the successful operation of the GCD circuit in processing input values and computing their greatest common divisor GCD. The GCD algorithm efficiently reduces two numbers to their highest common factor, which is essential for simplifying fraction and various arithmetic computations. This verification demonstrates the correctness and reliability of the design GCD module. That's all from me. Thank you.